Okay. In the previous lecture, we have stopped at this point, that is the solution of the quadratic equation k naught square is equal to half into minus b plus or minus square root of b square minus 4ac. So here minus of minus plus, here k square plus kn square plus or minus square root of b square, here we have substituted minus 4ac, 4 into this, and here you are getting. This is the solution of the quadratic equation. Here this is equal to half into k square. Substitute the value for kn square, okay, plus k minus 2 pi n by a whole square plus or minus square root of, right, substitute k square. Here just observe here, k square plus kn square can be written as k to the power 4 plus kn square whole square, kn to the power 4 plus 2k square kn square minus 4k square kn square plus 4 gamma square cn star. See here, when you observe this equation, you can observe 2k square kn square minus 4k square kn square. It becomes what? Minus 2k square kn square plus 4 gamma square cn star. What is this? K to the power 4 plus kn to the power 4 minus 2k square kn square. This is nothing but k square minus kn square whole square, right? So this is the final solution for k naught square. Now what you have to do is, you have to substitute cn equal to cn star is equal to its value, that is 2m magnitude of vn divided by h cut square gamma. This one should be substituted. You can recall this. You turn your notes, and in the beginning we have written the expression for Vn. I have rearranged the equation using the expression Vn for Cn. Okay. So this one you have to substitute here. So after substitution, what you will get? See, Cn star, you have to substitute this one. So it becomes, what happens? It becomes 4 m square vn square divided by h cut square gamma square, right? So here what happens? Here you are observing 4 into 4. You can write this one as a 4 square, right? So you can remove this 4 here. So everything is squared, therefore you can write this one as 4 square m square vn square divided by h cut square, right? So gamma square get cancelled, h cut square whole square, right? So therefore this is the expression. Now what you have to do is, you have to multiply both sides of the equation by h cut square divided by 2m naught. Multiply from this on both sides. So it becomes h cut square k naught square divided by 2m naught or 2m. Yeah, I think earlier you have taken m, therefore you can take m, 2m. This is equal to h cut square divided by 2m. 2 into 2 here, it becomes 4m. Rest of the terms remain as it is. That is k square plus k minus 2 pi n by a whole square plus or minus square root of, you can write this one as k square minus k minus 2 pi n by a whole square plus 4m vn by h cut square whole square. Right. So here now just you have to at the band edge, as we discussed in the previous lecture, right? Band edge means what? That is k is equal to kn is equal to n pi by a. Positive n indicates the upper band edge, negative n indicates the lower band edge. Just n pi by a. When k is equal to kn is equal to n pi by a, what happens here? It becomes, I can write this as E of k, energy of the electron in the periodic potential. E of k is equal to h cut square by 4m, see, k square plus k minus k is equal to n pi by a, n pi by a. So 1 n pi by a minus 2 pi n by a, that is minus pi n by a whole square, that is equal to pi n by a whole square. Pi n by a means what? Again it is k, it becomes k square. Right. Plus or minus square root of, here again k square minus k minus 2 pi n by a means what? Again it is nothing but k square only, right? K is n pi by a minus 2 pi n by a minus pi n by a whole square. Pi n by a is nothing but k square. K square get cancelled. What else remains here? The remaining term is 4m vn divided by h cut square whole square. So square root of this is nothing but this term goes, right? This is the expression you are getting now. So therefore what happens here? Just k square plus k square, 2k square, 2 divided by 4, again here h cut square, k square divided by 2m you are getting, right? So then plus or minus h cut square get cancelled, 4m get cancelled, remaining is vn. So therefore this is equal to, what you can write, h cut square divided by 2m, k is nothing but n pi by a, right, whole square, k square, plus or minus vn. So I can write this is equal to E of k is equal to, this I can write as En plus or minus Vn, right? So that means at the band edge, the maximum energy at the upper, when the electron, you consider this is the band edge, this is the upper band edge, this is the lower band edge. when it reaches upper band edge, its energy becomes En plus Vn. When it reaches here, its energy becomes En minus Vn. So therefore electron moves here. Then afterwards what happens? To strike this, in order to move beyond this point, an electron is not possessing the sufficient energy and it will reflect back. Similarly, here also the same situation. Therefore, we can say that when the electron reaches to the band edge, electron undergo Bragg reflection. So here electron undergo Bragg reflection and it is accompanied by a discontinuity here. Electron is not able to move. That means what? The region where the electron is not able to enter, that region is nothing but energy gap. This is nothing but energy gap. Let us visualize this one in terms of a graph. Right. So let us you consider along the y-axis we are taking the energy of the electron and along x-axis we are taking the value of k, n pi by a, n is equal to 1 plus pi by a, n is equal to 2, 2 pi by a, n is equal to 3, 3 pi by a. For negative integers, minus pi by a, minus 2 pi by a, minus 3 pi by a, and so on. Right. So that means just draw the dotted lines here. See, as you know, E is equal to h cut square k square by 2m. So that means what? It is the equation of a parabola. Therefore, the E versus k graph is a parabola with discontinuity. Right. So here you are getting this. So here this is the case. Then see, this is E, this is E1 minus V1. If it is V1, this is E1 plus V1. So then at here between pi by a and 2 pi by a, what you have? Energy gap here. See, then you are getting like this. Similarly, the case here you are getting and it continues. Just observe here, when you consider this height and this one is broadened here compared to this, but this is the energy gap. When you observe here, the width of the energy gap here, E1 minus E1, E1 plus E1. So what is the energy required? That is 2V1. Here it is E2 plus V2. This is E2 minus V2. Difference is 2V2. 2V2 is less than 2V1. Therefore, while drawing the graph, you take care that so this width reduces. Next, if you go for third one, again that is 2V3 is less than 2V2. That means energy gap is reducing as you go for higher and higher values of n. That means it is not symmetric for all bands. That one you have to understand. Here you can observe the formation of energy bands. If you have any doubt, you can call me personally and you can discuss the situation. Thank you.